trends and challenges in IT industry. We apologize on behalf of the Department of Computer Science and Engineering for the delay that has been caused. We had some technical issue, so apologies from our side. Now over to the chief guest. I'm very happy to introduce to all of you Mr. Manuel Soundararajan, Digital Transformation Architect, Department of Justice, New South Wales, Australia. I'm very happy that he accepted our invitation. And then thank you, Mr. Manuel, for spending your valuable time with us. Just a small introduction about Mr. Manuel. Mr. Manuel completed his BE in Electronics and Communication from Bharatiya University. He has a certificate in General Management and Information Technology Project Management from George Washington University. He has over 24 years of experience in the IT industry. He has worked as a network engineer in Datacraft and software, and he has worked for Cisco for more than 18 years as a digital transformation consultant. He is currently working with the Department of Justice, New South Wales, as a digital transformation architect, and his responsibilities are taking care of the department's connectivity, mobility, collaboration, and security strategies. We are very pleased to have such an eminent personality with us, and it is now time to listen to Mr. Manuel. So I hand over the session to Mr. Manuel. Manuel, you can take over.
Thanks, Sanita. Good morning, everyone. First of all, thanks for the opportunity by all the faculty members and the principals of R.M.D. Engineering College. I'm excited to be here to share what I think about some of the market trends in the area of technology, specifically around networks and cybersecurity. We already lost about 30 or 45 minutes already, so let's get into it right away. So let's look at some of the objectives of the sessions. When I talked to Ms. Anita in the beginning, we were trying to find out what will make a good topic in the area of networks and cybersecurity, right? So I came up with a few things, right? First of all, understand the protocol enhancements in software-defined WAN, its benefit for secure data transport, hybrid IT and the capability consumption models, modern cyber threats, and the use of zero trust model and how to combat cyber threats. And there is a question at the end of it to understand the effectiveness of this presentation, right? Do you all think that's a good objective for the session? I actually personally then thought it'll be a kind of a dry and boring session that I'll make most of you sleep, right? So I decided to have a little bit of a different objective. So the real objective is here, right? I'm going to try and make an attempt to reaffirm your choice of either teaching or studying technology. That's probably your best decision that you have made, right? Because this is a great time to be in technology. So I'll try to do my part to reaffirm that. I also will make an attempt to inspire you to take some special interest in the area of technology developments, specifically around the areas that I'm specialized in, particularly networks and cybersecurity. The third one is to encourage you to take some proactive initiatives to keep in touch with the market or the industry, right? And how you can help your students get into the workforce. And there's no question at the end of the presentation to understand the effectiveness, right? So we're all good. So why studying technology is the best choice, right? We're all in the middle of a pandemic, so we can't have a presentation without mentioning COVID. I think we lost the marks there, right? So this one floats in the internet quite frequently in the last month or so, right? Most of the organizations had a CEO, CTO role, or some organizations have a chief digital officer role, right? And usually they are responsible for the digital transformation of the company, taking technology solutions to address business problems, right? And it was on for a while, right? The digital transformation has been around for the last 7-8 years, the terminology, right? And yeah, the progress was pretty slow, right? And some companies found the compelling need to do that. Some companies did not do it, right? Or they've been talking about it, did not do much around the digital transformation, right? And COVID came and changed all of that, right? So it's a very appropriate answer is if someone has done the digital transformation in an overdrive mode, it must be the virus and the pandemic. This is mainly because the compelling need is the best one to drive technology transformation, right? Previously, everybody had an office to go to, and they're all congregated in meeting rooms and everything. And the technology was built around campuses and branch offices and data centers and those kind of places, right? Suddenly, everybody had limitations to isolate themselves, to go back into their house and still be productive enough to run the business, right? So that's where all the technology things were questioned. Is that, do we have that capability? Do we have this to enable our workforce to be completely not coming to the campus offices, but still be able to do 100% of the job? Most of them did, actually. And the last time I visited my office was about 4 months ago. And in Australia, government offices are considered to be more like you come to office every day and sit in the chairs and do your job, right? And if the governments can enable with available technology to put most of their workforce in the remote area, in their houses, wherever comfortably isolated, then I think the technology has done their part. So rapidly, the digital transformation journey has taken a rapid over. Someone wants to say something? Sorry, I keep going. So some of the reasons for this particular transformation was driven by COVID is the user experience is top of the chart, right? When I say user experience, when you talk about government organizations, they look at citizens' experience, how the citizens of the state or the country interact with government organizations for doing their day-to-day stuff. So whether it is, interacting from a justice perspective or health or education perspective, they want the best user experience. And that experience is not visiting an office and standing on the queues for hours together anymore. They want all their applications to be on their mobile so that they can do these things in a comfortable time they can when they have time, right? And when you look at the job industry now outside the technology, every non-technology space is enabled by technology, right? If you take just higher education for us, we use collaboration technologies such as Zoom and WebEx and other things pretty frequently. So this is how we collaborate with people. This is the new normal, right? And for safety and efficiency reasons and for saving costs, automation, for example, is has picked up as well, right? If people can't visit factories, right, due to health concerns and things like that, the production stuff has to run. If we need to make masks, some missions have to run and they have to produce masks for the pandemic, but people can't go there and assist in the production. So which means automating most of the production environments is essential, and technology enabled most of the automation. And there's quite a lot of radical transformation in that space. Industry 4.0 and all of that is enabled by technology again, right? The last but not the least one is about the housekeeping elements that most of the companies actually had an opportunity to do that. Well, I'll give you a simple example. If you move houses, you normally find a new place to move into, and you put everything in your box and get the movers to move it to the new place, right? After you end up in the new place, then you start doing your everyday thing and start slowly unboxing things and trying to put them back in the new place, right? You'll always find that most of the things that you brought in boxes don't get opened for a while because you don't need them, right? But you only open the essential ones, right? Which requires for you to run the minimalist type of thing. And slowly some boxes get opened in 6 months, some will never get opened, right? So exactly that happened in the technology space as well, right? When the compelling need of COVID hit the organizations, they actually found that most of the legacy and non-legacy services that they had, people are not using them anymore. And they only use some of the very essential and critical ones that they require to keep the lights on, right? So quite a lot of housekeeping was driven by the whole pandemic situation, right? And people said, okay, this is what we need, and we need it now. We will not need this forever. Those kind of decisions got made, and that was very aggressive, done over a very short period of time, right? So I also wanted to talk about further to the digital transformation. a institution who produce the future workforce, and you train students and educate them and give them the skills and the knowledge and the experience that they need, and transfer that into a workforce that the industry requires, right? And most of the research that I've done, and we see this in the market as well, I'm talking specifically about Australian market, but I hear that from my counterparts around the globe as well, including India, that the skilled people with the right attitudes are hard to find, right? So what that means is um, universities play a huge part in enabling that workforce, that the industry will accept them and turn them into productive employees, right? So from that perspective, even in a very proactive way, most mature organizations have a significant interest in enabling and developing the workforce for the future, right? If you take most of the top end companies, I'll name a few from a technology perspective that I know, Cisco, for example, Google, for example, all have some kind of programs running right from high school, right? Here in Australia, they call it a STEM program, the science, technology, engineering, and mathematics program, to enable people or even market to potential candidates to pick up technology as their study option in higher education. So that means in about 6-7 years time, they have a good skilled workforce. So at one point in Australia, around 2015, quite a lot of market research suggested that quite a lot of university students were picking up law and other arts and science degrees compared to technology, because at that point in time, their assessment was technology is boring. There's mundane type of jobs, and there's not innovation in there, all kinds of things, right? So, and from a pay perspective as well, which people think it's important when they get a job, there are quite a lot of better well-paid jobs in other sectors as well. So when parents and their children had discussions about what line of industry they want to get into, technology wasn't a preferred option. So most companies like Cisco and Google went out to that level and say, okay, you should consider technology because such and such things are better here, right? And based on all the efforts, and Australian market started to reflect a little bit, and this is the same across US and other countries as well, right? So the annual IT enrollments at the universities were 50% higher than the previous decade, right? And in Australia, there's quite a lot of international students come here for master studies and other things as well. So there are quite a lot of people got enrolled in the technology side, right? So which was a good outcome from a workforce perspective, and all the initiatives that IT companies did started working. The other thing research observed was the female share of the technology workers. They're all mostly ended up in teaching and other related jobs, but not so much ended in the frontline IT and engineering jobs or architecture jobs or even IT CIOs or CISOs, digital officers, those kind of jobs. There was less participation from the women folk on that aspect. So the research actually suggested that we should aim to get more gender equality into that as well, right? I think India probably reflects the same thing. So if we increase that population, there's quite a lot of good candidates can come out that can actually enable the workforce for the next generation, and we can meet the demand, right? So those two things came out of the research. So that's about my thinking around why technology is a good place to be in, and what are the market trends that's happening now from a skills gap perspective that universities like yourselves can actually bridge to, right? So let's get into a little bit of a technology segment information. I'll start with the networks first, right? See, traditional networks were very static, right? For example, the one I mentioned before is all employees went into some kind of a branch or a campus building, right? They had data centers, maybe one as a primary and one as a secondary. And the internet was connected to the data center, right, as a kind of a gateway service, right? And once in a while, users were allowed to be remote and they can take their laptops. Most of them had desktops, right? Governments still have quite a lot of population on their desktops, not laptops. Well, that's changing. Most people, a few employees had laptops to carry home, and they used their very slow DSL connection of some sort, right? Because 4G probably was expensive back then, and they try to download emails and do some minimal things while at home, right? But that behavior now is entirely changed, right? The user wants to carry all their work with them anywhere they like, whether it's home or when they're commuting or on the roads, or even a holiday place where they are. They wanted to take their work with them anywhere they want. When I talk about work, that's not just um, emails and browsing, right, which most computers can do these days. But we're talking about a business analyst want to run their business objects query, which is quite data intensive, right? And that needs to work on a remote connection, which could be DSL enabled or NBN or whatever that is, right? The technology right now allows you to do that, right? So the first thing is the location independence that's driving the changes on networks, right? Because users are now everywhere, not necessarily inside a campus building. That impacted the whole topology of how networks kind of connected together, right? The first example there is traditional methods always had a hub and spoke, the hub being the data center, the spokes are branch sites and campus buildings, right? But now that's kind of a mesh, right? And the second primary driver for that location independence and topology change is the workloads used to be hosted in the data center, either your own data center or some kind of co-location. Now everything is moving into the cloud. Since AWS, Google, and Microsoft got into the cloud game, all workloads are more cost efficient and when hosted in the cloud. So you don't really have to own a hardware or run an IT group to manage all that. Instead, you can just pay for what you use, right? And it's pretty elastic that way. And most of the workloads have been successfully migrated, right? And most organizations are in the path of migrating most of their applications into the cloud. So which means there is less and less dependencies on the data center, right? So the workloads move to the cloud, users move to anywhere, right? So which means the traditional model of hub and spoke is not relevant anymore, right? And the next biggest driver was the software intelligence of making network-based decisions such as routing or switching and all of that used to be delivered in custom silicon. For example, Cisco made switches that used to cost a lot of money, mainly because that cost is associated with Cisco manufacturing custom silicons, which is chips that are installed in every switch, which had the intelligence. So whether you use 100% of the feature or use only 10% of the feature, you pay for that silicon, right? And that model wasn't the right model from a consuming perspective. So everyone wanted a kind of a commoditized hardware, like a bare metal type stuff. Switching will happen on the bare metal chassis, but the intelligence for all the switching and routing comes from another software engine, a Linux box maybe. So people like, or companies like Facebook started making their own switches. So which means I don't need all the intelligence. I can get a bunch of software programmers to come and run the intelligence for me, how packets get from A to B. In the boxes are just boxes. I can buy it from anyone, right? The cheapest it can be. So this particular transformation drove a lot of companies to think again about how they deliver features, right? So most of the companies are in transition now. Arista, Cisco, Juniper, they're all in the transition now to say, move all the features to a central intelligence and the front end hardware will just dumb as it can be, right? And they're even introducing for pay for what you need kind of thing. So when it becomes a software feature driven thing, you can sell what the customers really want. So from that perspective, the software defined everything. It's taken quite a lot of importance in the market, right? There are practical issues with it, but most of them have switched to the model and they can deliver the features that the customers require in more on a subscription basis rather than, whether you need it or not, you pay for everything, right? And other enhancement that happened in the market is the connectivity enhancement. Right now, here in Australia and most other countries now have 5G in some kind of a test deployment, right? All our phones are 5G capable. Most of the phones are 5G capable, which gives the user a very reliable and a high bandwidth connection that you can pretty much a full-blown media environment within that, right? And Wi-Fi 6 is out, 802.11ax. Wi-Fi 6 is already out, and most enterprises are looking to enable Wi-Fi 6 on their campuses, right? Which is a pretty much high speed, what wires couldn't do 10 years ago, right? It's quite a lot of bandwidth there, and the quality of the experience for users is pretty good, right? And gives them seamless mobility everywhere they want to go. These days, everybody has got a home Wi-Fi connection that's quite capable enough, and the internet connection speeds are broadband, fiber, and all of that gives the user quite a lot of technology-enabled bandwidth to be able to do their work completely independently, right? And the campus side of things also is evolving. I'll have a few more slides later on coming up about a little bit more detail in there, but 802.3 BS, right? So that's 400 gig of bandwidth in a campus environment, right? We have 10 gig links on our thing. It's only about 10% utilized, right? But the market's actually, from a technology standards ratification perspective, they're already looking at 400 gigs on link speeds, right? So which means there is enough availability on the technology feature that the consumers need, right? So we have no limitation from that perspective, right? The last one is about consumption model, right? Even though this particular slide is a little bit of a summary, I'll go into a little bit more detail. The points that I haven't covered in this slide, I'll cover that a little bit detail on the next few slides as well. The consumption models for getting all this capability inside an organization is changing as well, right? Traditionally, the only model that most people knew was, buy the kit from a vendor, right? If you had your own skills, people trained, you just go and deploy it yourself, operate it yourself, right? Or if you don't have people skilled within your organization, go and enable a system integrator or a managed services provider to build it for you, and they'll transfer it for you to operate, right? Very static model, right? And pretty much that kit ended up in the organization for 10 years till they sweat it out and say, okay, it's end of life, we need to change it, right? So the consumption cycles and even upgrade cycles or replace cycles were long, 10 and 15 years in some cases, right? But so that means you can't simply adopt to a new set of features straight away because you had an old kit, right? But that's all changed now, right? And IT organizations within departments now, or major companies now act as kind of in a hybrid IT model, which means we are more like vendor managers, right? And we have set of service providers who provide the capability, more like the AWS, Google, Azure consumption model, pay for what you use, right? And then it is entirely based on what we require rather than what somebody has built for us, right? So we deliver the service to our businesses who needs the technology for doing their business. We get it from somebody else. We don't build it. So the option is now become, if cloud delivers it, go and get it from the cloud, right? If cloud is not an option, get someone else to build it and deliver it to you as a managed service, right? Those kind of options are pretty popular these days, right? And I'll tell you some of the advantages from a finance perspective, how that works as well, right? So we talked about the, let me minimize this quickly. We talked about the traditional connectivity, the location independence thing, right? So this is the campus model. We use something called the wide area connectivity to talk to the data center applications, right? And internet was the back end, right? Most applications are licensed modelings like SAP and Oracle and Microsoft Office emails, all of that were delivered as kind of perpetual type of licenses, one-off type stuff, right? If you pay for 1,000 licenses, you get it for the year, right? Something like that. So that model now, with the adoption of cloud, has actually changed the entire way that you consume applications, right? If you had a few thousand application users, you only pay for that particular month how many has been consumed dynamically, right? So which means that the efficiencies have been built into the usage model, right? So the traditional model has evolved into something like this, right? The departments have got somewhere around 600 odd sites, right? Department of Education in the state has got more than 2,000, 3,000 sites like schools and other things, right? So that model is still there. But if you look at the last one, which is about the mobile users, that's actually grown significantly in high numbers, right? That is because of everybody has got a smart device, either a tablet or a mobile phone, which can do most of the applications they need in their handheld, right? You know, email is a minimum thing, browser is a minimum thing, all applications, including the corporate ones that you need to do your job. You need a banking application. They're all there in your phone, right? And app developers are quite aggressive in that way that, you know, all smartphone companies have built the stores, application stores to deliver you what you need. These days, there's application for everything, right? So what that meant was there's a sudden explosion of mobile connectivity requirements, right? And see what happened with the connectivity. The traditional WAN wasn't relevant anymore because if you're working from home or on the road, internet is your foundational connectivity because everything is internet, right? Because you don't have a dedicated virtual private transport link to connect you to the data host on the back end. Those days were gone, right? All connectivity methodologies such as MPLS, DDS, all of that, which was very expensive at some point, is not relevant anymore. Everybody wanted to use internet as their basic connectivity medium, right? People had concerns about security on the internet because it's a shared medium and all of that. We'll talk about some of the risks that using internet brings up later on in the security section, but most of them kind of got used to the way that internet being the primary connectivity, even though it is not quality of service enabled, it is not secure enough like direct private links and all that, but people are okay with it because they do their banking transactions on their mobile phone connected on the internet, right? So why wouldn't I not do my office work through an internet link if it's available, right? So the argument was pretty simple and everybody was ready to do. However, the chief information officers and security people inside the companies were concerned with a lot more threats using the internet. We'll come into that detail a little bit later, right? On the right-hand side, so we still have the data center. We still have a footprint for legacy applications, which are homegrown or developed by our own people, which cannot change over time because of its significance and importance to the business. Not everything or not 100% of the application can go to the cloud, right? There could be legislations that does not allow data to go into a cloud environment like AWS or Azure. It needs to be kept local, right? Because of compliance things like certain health data can't go, certain crime information and privacy data cannot go to the cloud. Those kind of things will still require data center, a private cloud type of environment, which the organization will maintain it themselves, right? But that also can be maintained by somebody else, but it has to be owned by them, right? You can't push it into a public cloud, right? But most other things such as, you know, Office 365, Salesforce, right, and Box and Dropbox and all those other things, which are considered less data classified or no classified data goes into that kind of environment, all of them can be moved into the cloud. So which means these users on one side can choose their best path to go to their application directly without having to go to the data center, right? And most companies are doing the transition as we speak, right? Traditionally, everyone went to the data center and from the data center, they went to the internet. Now, if I have a path directly from my home or from my mobile connection directly into the internet, why should I go to the data center? Because it's another hop. Then why should I pay for additional bandwidth and everything? So it happened that way. And this particular change is quite rapid, right? The changes that are happening here, the technology is already there, quite mature, stable and everything. In some elements, the value versus the complexity is questioned, right? For example, the markets actually actively marketing the SD-WAN and SD-access type of technology. All companies in the IT space are pushing for software-defined WAN, right? Um, while the technology is very good, the problem with that is the additional complexity of overlay networks, right? And that means additional hardware, um, some kind of a responsibility mismatch between service provider versus who owns the service end to end, that kind of issues. So that the market will figure the solution to that eventually. But for now, it's only some of the compelling cases of um, certain organization require you to move into the SD-WAN space. For example, education is a great thing. Retail is a great industry to adopt software-defined WAN because the structure of their business is like that. More number of stores, little connections, less application intensive. Those things are okay for a software-defined stuff. Complex legacy applications with 50-50 cloud presence still use a combination of both SD enabled networks and some of the traditional ones as well. So that's what I mean by value versus complexity is still debatable out there in the market. So eventually in the next 5 years, everyone will transfer into some kind of internet-based software-defined connectivity. So that's pretty much the connectivity between users and their workloads, right? So what happens inside the campus, right? Campus taken a significant change too, right? To start with, the technology folks designed all the campus network in a very hierarchical, modular type of way, what they call the core set of devices, and there's an aggregation every floor, and the users connected to what they call an access switch, the picture on the top, right? What we call that is a spanning tree design, right? Back then, most of the links were like 100 meg gig links, right? And the cost of those links were pretty cheap, right? Over time, the cost of those things have come down. So most of them were afford to keep half of their links in some kind of a standby mode. So that's the traditional technology, right? So if you had two links connected from one of the access into the aggregation, one of them was in an idle state, waiting for a failure to happen, right? You know, this is a redundancy type of thing, right? And that's how the protocol was built, right? But suddenly over time, the bandwidth become 10 gig and 100 gig and 400 gig. Those connections and the hardware they came up with it are pretty expensive, right? So if you paid for a 100 gig link in your campus environment, you don't want to keep that in an idle standby state. You want to use that. You want your users to consume the bandwidth enabled by those links and have a better experience. So that particular need drove the design changes, which is now called the leaf and spine, which means there's no such thing as blocking, right? This is my primary path. That's my secondary thing, which is not active. Will be active when my primary fails. That's not the story anymore, right? Everything will forward. If you enable a link between two devices, all of them are pushing traffic. So if I have 200 gig links, I have total of 200 gig available to me to push traffic through, right? So the customer demand that way has made most of the companies, Arista, Juniper, Cisco, all others in the space, to move the design into more like, you know, fully active environment, right? Even though there are redundant links in there, they're all active, they're all passing traffic, right? So you get better throughput there, right? And it optimizes the use of 10 gig and 40 gigs or about, right? And most of them don't even use layer 2 type of technologies anymore because layer 2 had issues, right? Because they are old, their protocol were meant for links that are not fast enough. Links were prone for a lot of errors and failures. These days, that's all changed, right? And if you're in the industry, ever had to build a campus network, everybody is scared of a spanning tree meltdown problem, right? Most of the first few years of my life in Cisco has been troubleshooting all the spanning tree meltdown problems that Yahoo had or Microsoft had back then, right? That's because the technology is built that way. And if you do something fat-fingered on a configuration on a switch, you can essentially bring down the entire network for Yahoo for a day, right? That's how the protocol wasn't that resilient, right? So the leaf and spine is quite adoptable. It's actually graceful for failures. If you do something wrong, it can heal around itself, right, on issues, right? So these are the compelling things that happen in campus, right? All these transformations, which I'll stop there for a moment from the technology perspective, right? All these network level transformations require skills in the market that help them with the change, right? And that demand hasn't gone down at all, right? Because these transitions that happen in the market are not like 10, 15 years apart anymore. They are very short-lived or short-spaced, right? From that perspective, there is constant requirement for engineering resource, analyst requirements, and other people, junior, senior type resources required to support customers with their journey, right? So that's why the technology market is booming everywhere, right? Where even take COVID, for example, if airlines industry was impacted big time because of the isolation, technology did not, right? People were constantly changing and bringing new capability because it has become an essential thing enabled for every job industry out there, right? The last one I want to talk about the industry thing on networks is the consumption model. We talked briefly about this. Most companies now prefer an OpEx-based model, which means I get a lot of financial benefit if I pay for what I use on that year, rather than I had a few $1 million to spend for that year and never had any money to spend on the remaining 5 years on the term, right? And most companies don't have the luxury of having big money up front, right? And very less money afterwards, right? Most IT budgets now, or even business budgets for technology, is on that year, right? Depending on what the priorities come out. For example, in the state, when the premier in the state decides these are the important things for that year for the political party, they come up with certain initiatives, and the business will use technology to enable those initiatives for that year. So which means most people will prefer an OpEx-based model rather than a CapEx model. The OpEx is actually built on the hybrid IT model that I told you before, which is IT organizations don't develop software, or we don't build things, we don't configure things. We are more like vendor managers who get their services from other companies, right? So if you want a cloud workload to be migrated over to AWS, that's kind of readily available these days. You have so many options for you to do that, right? But if you take somewhat less cloud-centric service, let's say secure remote access kind of thing, that's not available as a service model anymore. So most companies now go to service providers and say, can you build that and deliver to me as a service capability? And most organizations are taking that request and delivering that capability. So hybrid IT is what's practiced most days. IT departments are more enablers, kind of arbitrators in the middle, and they go and deliver the business because their operational money on an every year is limited. Business has all the money. Business wants a service, not with a lot of time. Usually they need it in 6 months on a year. They want that capability delivered within that financial year. So which means you can't have that old IT model where I'll build everything and I'll operate everything. I'll skill my people with whatever I need. That model is not agile enough to deliver that what business needs, right? The hybrid cloud is also working very well, right? Legacy applications stay in the data center. Whatever can be moved over to AWS or Google works perfectly, all right? And these two models can actually interact, right? And there's no issues between having some part of your application component sitting in your data center, the more secure data stores, and the compute part of that sitting in AWS. That model's worked very well as well, right? So you don't have to move every component of an application into an AWS. So that kind of hybrid cloud works as well. IT as a service is pretty common these days, and that's get delivered in whether you want an infrastructure. I don't buy a computer, I buy computing as a service, right? If I want WebEx, I get WebEx as a platform, right? I just tell that many users and I get that completed. I have no lifecycle management requirements for that product. Somebody else manages for me, right? I just get that service, right? And you get SaaS products, PaaS products, everything as a service these days, right? So that's pretty much what I had about networks in general, right? And we'll stop there for a moment and we'll go into cybersecurity, right? Just wanted to check time quickly. So we do 40 minutes. Because of the shift that happened in the networks, right? I told you about the user being very mobile and anywhere, anytime, any device type of connectivity, right? And that actually brings along with it quite a lot of security concerns, right? Because when you get everybody inside a campus building, they always had something called trust zones, right? We'll go into the trust zones a little bit later. Before we get in there, we'll look at some of the threat landscape, right? What happened because of the changes that happened in the way people consume their information, the threats came with it, right? And these days, the threats are a lot more sophisticated than what it was 10, 15 years ago, right? And if you look at some of the top cyber attack categories on 2019, mobile is almost like 1/3 of it, right? And people are aiming to compromise your mobile devices, such as your phones or tablets, right, are quite a lot, right? And we're all aware of the ransomware thing that came up in 2017, 2018, the WannaCry firms and all that. They were pretty bad, right? Even for organization, even for individuals, a lot of people have lost their information or paid people to open up their information, those kind of to save their information. A lot of that happened, right? So those attacks are becoming a lot more sophisticated, and most of them, most of the attackers these days go after people with the financial motive behind it, right? They want to earn money as a trade, right? And there are specific type of things that we've seen in the market picked up quite a lot, and ransomware is a common one, right? And while we handle one ransomware, there's always another one, right? So what happens to the ransomware is they are increasing, and they are diversifying on different things. Like if you have a student device, they know what kind of things that'll go into those devices and how they value, for example, research data, right? If you had a ransomware attack on a university researcher, you've got a lot of data sets over time, and one fine morning your laptop is locked because you browsed a site which had a malicious content in it and locked your content, and then you would probably pay anything to get your research data back, right? And or lose it would not be an option. So ransom was pretty bad, right? And the threats were targeting increasingly mobile devices, right? And because of the numbers, the mobile devices have come up. All the hackers started targeting mobile devices, and it's pretty easy to target mobile devices as well. You get messaging, you get applications like for anything, which are mostly free these days, and people can actually download them and start using them without understanding some of the malicious intent behind those things, right? And the mobile things are quite successful from that perspective. And phishing is another one, which has become more sophisticated. About 2 weeks ago, one of the government organizations here got compromised due to a phishing attack, right? And they lost quite a lot of customer data on that attack, right? So organizations now are compelled to go after protecting their information assets and people safety from the cyber threats, right? And worms making a comeback. Viruses are not that popular. Worms making a comeback. WannaCry is gone. Bluecreep is coming back, right? So these are the constant threats that if you are a chief information security officer or an info security engineer, you need to be watched pretty closely and say, how do I protect my employees? Because I have no control of where they go, right? And in some cases, you don't even know who uses. Sometimes kids uses their parents' laptop at home, right? And at home, use an internet connection to do that, right? I can't actually block things. I still have to enable them to do their work, but how do I secure them, right? And you've probably seen quite a lot of marketing materials from companies like Google and Amazon about the use of artificial intelligence and machine learning, right? To do some of those modern technical things, right? Hackers are using AIs and ML sophistications too. They can get quite aggressive with some of those things. And the attacks are constantly learning as well. So once you have a threat management plan to protect some of that, they can learn that and adapt themselves to go around it, right? And I'll tell you what has changed on the security front, right, a little bit later. The organizations, when they build a cyber security management plan, usually don't have a lot of money to do that. Yes, it has improved from the past. 10 years ago, security budget was nothing. Nobody ever thought that security, threat management landscape is as important. But in the last few years, or I would say last 5, 6, 8 odd years, because of the media exposure and the importance of customer data in the internet, there's quite a lot of focus around that, and media comes up with a lot of information that's lost to attacks, right? So the awareness has increased significantly. So that means there are roles that are created. The Chief Information Security Office was part of a CIO's role before, but not anymore. Now they have a dedicated information security officers, dedicated teams to look at threats and everything, right? Every organization now has to produce a risk-based cyber plan. And you take government, for example, here, you're supposed to come up with all your risk-based security threat management plan, tasks and items, and report all your breaches mandatorily to the government, right? So that's how it's become. So what that means is everyone takes threat management plan seriously. They're all risk-based, right? And they usually go around building their threat management on 3 different things. Companies call this an attack continuum, and some companies call this a before, during, and after. Like everything is attack centric, right? What can you do before an attack happened, right? And what can you do when you detect an attack, right? Or the last one is when the attack has happened, right? How do you respond and recover from that, right? Based on these 3 steps, different companies are built a little bit differently. Some start with identify and protect, right? And then go a little bit beyond respond, they say recover, right? But primarily, these 3 steps are vital to a threat management plan, right? The cyber security management plans usually addresses one of 3 things, right? What I call an AIC, right? If a network is compromised, or if an organizational service is compromised, for example, due to a denial of service attack or locking down accounts and things like that, you impact the availability of the service, right? If someone targets a Zoom instance that's running in the cloud somewhere, right? We all lose the availability of the Zoom service. We can't run meetings. So that's your first A. The availability of a service get compromised because of an attack, right? The second one is about the integrity of data, right? When the data has to be sent from one place and received on the other, it has to exactly match the same way it was sent and it was received, right? And if there is a difference in the data, what it's sent to what it's received, then the data integrity is compromised, right? And the last one is about the confidentiality, right? If you want to have your information within your control, you can't get that information leaked out to the public or any other party. We're not supposed to view that data, right? So that's the confidentiality element of this security landscape. Different industries view this differently, right? Some take availability more seriously. Banks take confidentiality more seriously. Manufacturing, for example, takes data integrity more seriously, right? But every security measure is to address an availability, integrity, or a confidentiality aspect, right? So I'm not going to go into every one of those little blocks up there on the right? In the security management plan, usually have these 3 stages. We talked about that, but every step there has got some kind of a process to address that. For example, we'll cover a few in this picture, right? If you look at the protect thing, right? Most organizations now work on an assumed breach plan. What it means is, if you thought your network or your organizational services not being breached, you probably did not have the right tools to know about it, right? So most organizations look at some kind of an assumed breach scenario, right? But they do quite a lot of protect mechanisms as well, right? And that reduces your breach surface or an attack surface. But nevertheless, some of the protect mechanisms are still effective, such as vulnerability management. For example, if you roll out a new service, there are consultants, junior consultants, they come up and do a check on, okay, have you rolled out a new browser? How is Windows 10 capable from a security perspective? Are they protected enough to be delivered as a standard operating environment for everybody in the organization? They do vulnerability management on that, right? So people do penetration testing. This is like more like controlled hacking, and we try to penetrate into new systems and say, what if I was a hacker and try to break this system? So we do all the testing, we produce reports and say, okay, that system is quite solid. We had some issues which we fixed it, right? And we do still do quite a lot of perimeter controls. Like, what I mean by perimeter controls are devices like intrusion detection, firewalls, and things like that. While most of the workload has gone into the cloud, we still have a data center footprint, I've told you before. So which means as long as the data center exists, there is always going to be an external connectivity from the data center into the internet. So which means all your perimeter controls are still effective, right? And I need endpoint protection, right? Because I carry my laptop, I carry my tablet everywhere I go, I need that device to be protected for malicious content, right? And how do I know that the website that I visit while I'm at home is not compromised, right? So you need endpoint controls. Like if someone tries to download a malicious content, botnet, command control type stuff into your laptop, you need an endpoint protection stuff to tell you that something is not right, right? And there are some popular companies in that, McAfee, Symantec, they all do endpoint protection pretty well, right? So when those companies detect some kind of intelligence-based system tells them, this is the signature we're getting, there's a particular code in the internet trying to be downloaded to most devices who access this particular site, they can send that intelligence in real time to most of the endpoint protected devices. So which means if that particular behavior is experienced on that device, it tries to save you from that, right? So that's how real time it is, right? Then let's assume that none of your protecting has actually worked. You actually are breached, and when you detect something is not right. For example, one common thing that happens is the executive employees in organization get targeted for their email accounts, right? And suddenly one morning a CIO gets up and he gets his email account locked up, right? And there is a control in Office 365 or Microsoft email that if you fail your passwords like 6 or 7 times continuously, and it'll lock your account, then you have a certain procedure to go and unlock that account, right? Let's say that that particular CIO traveled to a country, China somewhere, right? And trying to open his email, and it's nothing worked for half a day, right? He lost his service, right? Someone is trying to use a kind of a dictionary attack on his account. So the system has actually blocked that account, right? So how do I detect this and get around giving that email connection back to the user who needs it kind of desperately, right? So those kind of things require some kind of threat intelligence and also some kind of log analysis behind that, right? So if I know a particular account has been blocked, before he even opens up, I get notified, then I go and release that account before he even knows about it, right? Those kind of things. And what if it was compromised? What if you lost some of your information that belongs to citizens or health records for someone in your state, all of that, or even financial information such as credit card data and all that? There is a certain set of procedure that we need to respond. How do we protect? We need to inform the users about changing their thing, disabling their cards. Whatever that needs to happen has to have a certain structural process to go back to the market with. Otherwise, your organizational image is at stake, right? And it'll be on the media everywhere. Sometimes people lose jobs over it, right? So it's important how your response plan looks like. First, you need to contain that breach, and then you need to go back and protect all your data so it doesn't go beyond your control. What's lost is lost, but you can fix that, but at the same time minimize the impact. One thing I want to mention from a security perspective is because I told you about the whole topology change of people moving everywhere, right? That also has a impact on how people securely access data, right? Traditionally, organizations are what they call a zone-based model, right? This worked pretty well for the traditional connectivity, campus, branch site, data center, right? Everything in these three locations, what we call as an internal zone, right? Then we have something called a demilitarized zone, DMZ, which is the interface point between internet and my trusted zone, right? That's where the services such as firewalls and everything come into play, right? I have some devices there which takes care of when I try to access the internet, protect me from external threats, right? People always thought internal networks within our own employees are 100% secure. The threat, if it has to come, it has to come from the internet, right? But that's not true anymore because the devices that have gone out of the campus, they enable it on their home, enable it on their 4G network while they were commuting. So which means there is no zones anymore, right? Because of the mobility requirements that people had, the zone model is broken. So what they needed was something called a zero trust model, right? And zero trust did not take into account where the location of the user was. All it cared was what application trying to access, right? Do you have the right for it to access that thing? How securely can I provide access to you, regardless of what connection that you use, right? So the one in the picture there, from going from this to going to another model on the right, it's from a company called Zscaler, right? And they're kind of leading the zero trust model in my view. There are quite a lot of other companies do that too, but this one's got quite a lot of traction to it, right? So regardless of what device you use and everything, if you require a particular secure application connectivity, they enable just that, right? It doesn't have to be a network-centric view at all, right? So that's pretty much the technology side of things, right? We talked a little bit about networks, and we talked about how networks have changed over time, and the market's on a transition to enable software-defined stuff, right? And from a security perspective, the changes in the networks and topology has brought in additional cyber threats, and you have a cyber management, threat management plan, detect and respond plan to address those requirements. And all of them have triggered jobs, right? More jobs, right? I think one of the in-demand jobs in here in the Australian market is cybersecurity specialists and folks, right? You are a junior analyst to a cybersecurity consultant. They're on really high demand, right? So all of that comes and filled up by potential candidates coming out of universities. So I actually thought about, based on some of my interactions previously with universities here, University of Technology, Sydney, and a few others like Royal Melbourne Institute of Technology, we had several discussions about getting help from the university folks into the company to give them a little bit more about or beyond what they learn in their curriculum, more practical view of what the market is. So I thought maybe I'll have a few slides about what my view is on that front, right? So the faculty connecting with the industry. So that's the next section, right? So how do we prepare what we call the gig economy, right? And in the past, people thought jobs as a full-time job on a permanent basis, right? That's changing a little bit now, right? You know, if you look at Google, for example, most of their current employments are based on gigs, particular small gigs, right? So if you are capable enough, you'll get a lot of gigs, right? So based on that, there's no concept of full-time employment or a full-time job, that kind of stuff, right? Depending on your skill set, you have a lot of work, and you're capable of doing all of the delivering all of that. It's on a gig by gig basis, and companies are quite okay with that model. And if the workforce is set up that way also, then there's quite a lot of synergy between those models. So how can faculty influence that? So faculty can play a significant role in setting up that workforce, future workforce, right? We all know that completing the curriculum is very important, right? you have to do your subjects in 4 years of your study, but for 5 years of your study. But markets requires a lot more skills beyond what's actually taught in that, right? I think in my discussions with your staff, I understand that you do recommend a lot of other industrial certifications or industry certifications to get people upskilled to build a gap. So that's a good thing, right? For example, there's the AWS certifications, Microsoft certifications. There's other certifications, Cisco and other companies, if you're interested in the networking side of things, cybersecurity, there's quite a lot of CISSP, oh, name it, the multiple three-letter acronyms in there. You can get upskill there. So that those industry level certifications while in college gives you an exposure to go and understand the market a little bit better. So when you finish your studies and go out there, you are a lot more prepared than just the curriculum information, right? So faculty also should try and help the candidates to enable their skills to work independently, right? Without, they are responsible for their own development, that kind of approach, right? So which means that will go a long way, right? If you nurture that mentality within the candidates, then they even outside their college days, they can actually go and see what is required and how they can contribute to the industry directly, and then landing in paid gigs is a simple thing after that, right? And this does not have to wait for a candidate to get out of college as well, right? Most organizations now looking for help from colleges, campus interviews and all that, and placements are good. But what I'm saying is, even when the students are in the pre-final days, you can still give them smaller gigs that the company requires through some kind of partnership with companies outside to give smaller projects. But research is a very, very common thing that we do here. We go out to certain universities and get a couple of candidates to a particular research report on an area that we wanted to explore, right? Which is more time consuming. That's a perfect project for a university candidate. We'll do that too, right? Those kind of things will give them that exposure to work with an industry expert at the same time trying to understand how the industry works. So so when actually they leave the college environment, they're not just going out to just a transcript. They're going out with a portfolio. For example, if you had a LinkedIn profile built up, you can have a portfolio of things what you've done in your college along with your curriculum, than just a particular set of subjects that you have done as part of your course, right? So to continue on, the preparing the workforce for the gig economy, right? And so not everything has to be paid as well, right? But that's the other thing, right? The economy aspect of it, right? But these days, there are several online things that I use and my colleagues use, right? Coursera is one of them from an education perspective, right? There's quite a lot of content in there, very useful content that can educate both the faculty and the students to understand what's current in the market, right? Mostly at no cost, right? But if you want accreditation, you probably pay for it, right? Because of the media explosion on YouTube and other online content, there's quite a lot of things that you can consume to actually prepare the workforce, right? And from an exposure perspective, I personally believe that volunteering opportunities are great for candidates, right? This is not paid, this all can be paid, but someone wanting the time to do a few things, research, as I mentioned before, is a common thing, right? There's also another thing that I've been discussing with some of the other colleges is to create a mentoring program, right, to access to industry experts, right? Even let's say that you come into a workforce, right, to develop your career in a long-term basis in an industry, you require some kind of mentorship within an industry to guide you through different steps of the way, right? And I had people throughout my career mentoring me in different stages, right? When I was an engineer, I had some senior engineers mentoring me. When I moved into consulting, there were people in the consulting area that have done quite a bit of work in consulting, guide me through some of the nitty-gritties of the work, right? So we can enable something similar for for university candidates as well, right? As I said, there are structured programs in our state here to have an access to industry experts, even when you're at high school. When you're about to make a decision what course you want to take in uni, you can actually reach out to a mentor. If you want a technology mentor, the system can allocate you one. And this is not a huge thing. It could be just an hour of in a month. You want to have a couple of conversations, bounce your ideas and say, I want to pick up networking, for example. I want to pick cybersecurity. I want to understand how that works. Right? Maybe that industry expert can guide or give their view about the things, the same like what I delivered it here today, to make things more interesting, right? And there are also other in-campus programs that organizations proactively come to institutions and run programs, right? So that also helps, right? And the last one is the experience element. Again, volunteering. Through volunteering, you can gain some experience. So when you get out of the college, you know how to move a workload to AWS, for example, right? Because you did a volunteering gig that allowed you to, or had that opportunity to do that. So you're familiar with how elastic compute works, for example, right? And faculty can also establish some kind of a three-way partnership between an organization, student, and the faculty, right? So it could work wonders for a candidate as well as the image of an institution, right? Because they are critically supporting the generation of the next workforce. Yeah. I'll stop there. I think we've done pretty well from a time perspective. It's kind of 2 past the hour here. So I had quite a lot of research type stuff to support the theories that I mentioned on this presentation, which is covered here in all the references and attributions, right? So when I make a statement, I like to have some kind of references to other research data. So that's all covered there if you want to have a read later on in your own time. So that's pretty much it. So let's have a few more minutes or 10, 15 minutes for questions. So Anita, if you want to take back control and
Yes,
look
Mr.
at any of the
Manuel.
questions, I'm happy to answer them.
Yes, Mr. Manuel. I'll just read out a few questions which have been posted in the chat box. One question, the first question is there any open source app for an Android phone to find out whether our voice is being recorded on the other side without our permission?
Interesting question. No, actually, I'm not aware of one, right? But these days, I could answer it in a different way, right? It is not in the control of any sender of that information to understand whether the other party is recording that, right? And it possibly can happen in many ways, right? In the industry, about 10, 15 years ago, what we called a nice logging system, right? The product is called NICE, right? But what it did was it actually or kind of a forked voice media stream into a recording device, right? And we did that for compliance reasons, right? Banks do that when contractual obligations are made on phones. Insurance companies, for example, required to record every one of the conversation, right? When that happened, the user did not have any idea on the other end whether the call is recorded or not, right? So it is kind of a responsibility of the user to understand whether they can say something that they don't want it to be come back to, right? If somebody recorded and played back to them, right? And you have no way of knowing that, right? And I couldn't look for a particular app that does that or tells you that intelligence, but I know of there are so many things in the industry today that records your conversation, even for law intercept and all that, right? American NSA does that all the time, right? And without you knowing about it, right? But I don't think giving you that app is the right thing to do in several ways, because you should be aware of your content being exchanged in the media, right? If you are not talking the right thing in the media, then there are intercepts to track that and come up with different AIs relating to that. For example, if you use a certain keywords in the conversations in America, you've been monitored, right? And same in Australia as well. So which means if you give that aspect to the user that their conversation is being recorded, then um, people don't know actually exchange all that information. So I don't think that'll ever happen.
Another question, Manuel. Is there any software platform to decrypt the content which is encrypted by ransomware attack?
Depending on the complexity, right? The answer is yes. Yeah. Depending on how that was done, right? There are different ciphers that people encrypt through ransomware, right? And in my experience, probably lower end of it, like 20% content can be decrypted and save your data, right? Depending on how complex that lock was, right? In the defense environment, if the attack was related to an encryption code owned by somebody else, they can decrypt it pretty quickly because they do have a lot of hardware encryption modules that can decrypt pretty rapidly as well. But from a user perspective, like for example, if my laptop is impacted by ransomware and I got my data all encrypted, there is very less ways that I can decrypt that, right? Because I don't have the necessary tools inside my remit to be able to decrypt that, right? So the best option for me would be to go and kill the entire instance and rebuild that using my data replication suite, right? And most companies go down that way. I think there was an example that I read a few weeks ago. There was an attack on an US government organization. The ransom amount was $52,000. They actually went and spent about $2.5 million, but not paying the ransom. But they actually fixed the entire thing by rebuilding the service. They killed the instance and they rebuilt the service. It cost them $2.5 million, but they went down the path rather than paying the ransom.
Yeah, the next question. How do I protect my password in online banking?
How do I what? Sorry.
How do I protect my password in online banking?
Right. Okay. Most. Okay. Well. Okay. There's two ways that you can answer this thing, right? We used to have flyers sent out to people saying that your password is on. It's not to be shared around, right? So that's one simple way from a cultural or behavior perspective, right? Because security always starts with the behavior, right? So don't share your password around. So that's one thing. Second thing is, if you enter your password in there, right? These days there are multiple mechanisms to secure that on your app, right? Most of them come up with an SSL type of connection. You see a little lock up there on your browsers when you access that. That means the moment you enter into that site, everything is encrypted. So the chance of everybody decrypting that is highly unlikely, right? So the protection comes in a different level. One is you access information that has all the controls. For example, if you make a financial transaction, make sure that transaction is verified by some of the popular people in the financial area. For example, Visa verifies all your financial transactions, so which means you can be very safe using your password in that environment, right? If State Bank of India issues a particular application for your mobile app, that's encrypted as well, so that's okay. So the technology gives you enough protection for those passwords. But again, give the password to someone else in the wrong place, publish it in the wrong place, or share it around in a collaboration app or a Facebook or something, then it's a behavioral thing that needs to be dealt with rather than a technology issue. Yeah.
Thank you, Mr. Manuel. I hand over the session to Dr. D. Rajalakshmi to deliver the vote of thanks.
Thank you.
On behalf of the management, principal, deans, and HOD CSE of R.M.D. Engineering College, I would like to extend our heartfelt thanks to Mr. Manuel Soundararajan for delivering this session. Thank you, sir, for the wonderful session. We are very grateful for the time and effort you took to share your thoughts with us. I extend my sincere thanks to management, principal, deans, and HOD CSE for organizing this FDP. Also, I would like to thank the participants to take part in this FDP. Thank you.
Thank you very much.
Thank you, sir. Thank you, sir. Manuel, sir.
Thank you very much. My pleasure.
Thank you, Manuel. Thank you so much for joining us. Participants, thank you for your overwhelming response. I know many of you were not able to join us. We apologize for the inconvenience caused, and we have posted the feedback link here. It will be posted in the YouTube chat box as well as in the Telegram group. Ask your friends to fill it up, even if they're not able to participate in the Zoom. Ask them to fill it up. Very shortly, today afternoon, we will be uploading this video on YouTube. So you'll be able to view it on YouTube. Thank you. Thank you for all your cooperation. Thank you.
Right. Close the session.
Yes, sir. Manuel, thank you so much.
No problem.
I'll call you back later. Yeah.
Thank you.
Thank you.
Cheers.